Okay, we're going to look at some factoring techniques and start off with factoring a square minus a square, look at a cube minus a cube, and factor by grouping. So let's take a look at the first little example here we have. We see 2x to the fourth minus 32, and notice that 2 and the 32 aren't perfect squares, but they are divisible by 2, so we'll go ahead and see if we can't divide a 2 out of that. So if you divide a 2 out of that, you'll get 2 x to the fourth minus 16. So then if you'll notice that both 16 and x to the fourth, you can take the square root and get an even result from that. So that's exactly what we're going to do. We're going to break it up into a square minus a square, which we should be all familiar with. So we still have our 2 remaining out there, and now we have x squared minus 4, and we have x squared plus 4. Well, if we look, we see that we have a square minus a square here, and a square plus a square, and we can't break down that square plus 4, but we can break down the x squared minus 4 again, so we'll do that underneath here. So this first quantity, x squared minus 4, is just going to be x plus 2 and x minus 2, and then we'll just rewrite that square plus 4 again, and that's this equation broken down. Okay, let's take a look at number 6, which is you notice that there's 4 terms and there's nothing in common with any of the items, so we can't add or subtract anything. So we're going to just try this grouping. We're going to set it up into 2 separate groups, and we'll do one in blue and one in green. And we'll look at the blue group first, and we'll notice that they each have an x value, and this one has x to the third power, and this one's x squared. So we can pull out at least x squared, so we're going to pull an x squared out of that, which is just going to reduce the power on the inside by 2. So we're left with 3x plus 1. Alright, so if you recall that this is the quantity that's being distributed, 3x plus 1. So in that green grouping that we have, we're trying to match this 3x plus 1. So we notice that both of these terms are positive, and both of the terms inside of here are negative. So we can actually divide out a negative 4. So I can erase that. So we pull out a negative 4. It means we're just dividing everything by negative 4, and that's going to give us positive 3x plus 1. And we just put the 2 factored items that we just factored out, and we'll make that its own group. X squared plus, x squared minus 4, and being distributed to 3x plus 1. Well, we can't break down 3x plus 1 any further, but we do notice that we have another square minus a square, so you should be able to recognize that pattern, and just give you the quantity of x plus 2, x minus 2, and then we just simply rewrite our 3x plus 1. Alright, let's take a look at the next little problem, number 7, and this is 2 terms being subtracted, and it's not a square minus a square, but we do have a formula for a cube minus a cube, and so we'll use that formula right here, and we'll notice that it's a minus b, and then we have a squared, a times b, and then we have b squared term. And remember, we use that SOAP acronym, same, opposite, and always a plus right here. So opposite of subtraction is plus, and always positive. So all we have to do now is identify what is our a and what is our b. Well, a is the cube root of the first term. In other words, it needs to be written like this. 3x to the third, and 64 is 4 cubed. So our A is going to be 3x, and our B term is just simply 4. So we just plug it in and set up the equation like that. So just be careful when you're doing this. So we have A minus B, 3x minus 4. And now when we square A right here, this term here, we're going to square both the number and the variable, so we have 9x squared. And then A times B is 12x, opposite, so it'd be 12x. And B squared is just 16. Okay, so that's an example of a square minus a square, and a square plus a square is factored using the same A and B, but we just adjust the formula. Alright, let's look at number 8. It's a trinomial, and we have, looks like we have something in common here. We can divide all three of these terms by 3. So if we divide a 3 out of there, we get 4x squared minus 4x minus 3. So let's use our crisscross method where we do crisscross and bottoms up on that. We'll do it over here to the side. Recall that you multiply the leading coefficient by the constant term out there, so we need to multiply to get a negative 12, and the two things that we need to find have to add to get negative 4, and that's from this term here. Alright, so what multiplies to get 12? 3 times 4, but that adds to get 7 or subtracts to get 1. 6 times 2 adds to get 8 and subtracts to get 4. So we're going to have some combination of 6 and 2, and since the quantity we need, the addition portion needs to be negative, we're going to make the bigger number negative. So that satisfies our situation. Multiply negative 12 and adds to get negative 4. So we simply set up our problem like this. Don't forget our 3 is still out there because we divided that out. And we have x minus 6. And then we divide it by the leading coefficient, which is 4. It's just part of our technique that we've used. X plus 2 divided by 4. Alright, so now we're going to look to try to reduce the fraction. So this fraction, 6 over 4 reduces to what? 3/2. And 2/4 reduces to 1/2. So remember, the bottoms up comes from taking the denominator and bringing it up in front of the variable x. So putting this all together factors out nice and clean. And we have 2x minus 3 and 2x plus 1. You can do a quick check by foiling this back. You notice that 2x times 2x gives me 4x squared, and negative 3 times 1 gives me my last term and a negative 3. And multiplying the two inside terms, you get, change colors here, you get a minus 6x. And when you do the outer terms here, you get a positive 2x. So that gives us our negative 4 that we needed, and looks like this problem checks out. Okay, look for another video. I'll do one where we are multiplying and dividing rational equations, and adding and subtracting as well.